Hey guys, welcome back to my channel. Tonight we're gonna explore the binary search, but before going into the actual algorithm, I just wanted to share with you guys um, the news that I got accepted to TU Eindhoven, which is like a university in the Netherlands, technical university, uh, for data science and artificial intelligence master, and computer science and engineering master. And I'm just telling it to you guys because I almost have no one to share with. Um, so I just wanted to show off. But I did my bachelor somewhere else in the Netherlands, of course. Um, but yeah, I did my internship in Eindhoven, and I'm really familiar with the city. I know that it's a good university. So yeah, I applied to this one. I just got in. Uh, I also applied to this one. If Although I'm not going to be able to enroll myself in this year, um, I can prolong this for 18 months, they said. So probably if everything goes by plan and I earn enough money, then I might go into it next year or year after. Um, yeah, I prefer CSE because I feel like during my bachelor, I've had some basic knowledge of artificial intelligence, and now I just want to go deeper into algorithms. And I have learned that during my exploration of algorithms with you guys, learning day by day, just really fun. So yeah, I would love to go into advanced algorithms, and to do that, CSE will be the best choice for me. Also, I feel like it's more well-rounded if you want to go into industry afterwards. Most people, some people go into research, but I would love to stay in the industry, and that's what I want to do. I don't know if for my first job I'll be able to get something relevant, like a software engineering, because I don't speak Dutch, and I don't also have a proper visa. I'm not European, so that's a big hindrance. But yeah, if we'll see where it goes, but probably not software engineering, although I really want to get it. Anyways, yes, so today we're going to explore the binary search. What is a binary search? Binary search is actually the first algorithm that made me decide to do this challenge because it's so powerful. So given a sorted array of numbers, you can you can you can find a specific element that a question is asking, usually a target from this array, within log n time. So that's a really fast time complexity because log n is always really fast compared to iterating everything and trying to find a number, because that might take um, more than n time complexity. So um, yeah, how would we implement it? Logic behind binary search is really simple, that we just have to know um, like this basic template, and we tweak a bit uh, depending on the question that we're trying to solve. But anyways, what we do is uh, maybe it's better if I just do it on Word document. So first of all, we declare two pointers. So we use left and right pointers in prefix sum and sliding windows as well. Uh, this time we're gonna use left and right pointers as well. So left and right pointer. and I'm gonna draw it here, an array sorted. So 1, 3, 5, 7. Yeah, let's just put it like 7 and 9. So left pointer will be here. So, and right will be on the last indices. So that will be 4, right? Left is 0 and right will be array length of array minus 1, right? So that will be 4. And these variables represent the inclusive bounds of the current search space at any given time. And while this left, so while left is smaller or same as right, we calculate the middle of the current search space. So that will be left middle equals to left plus right divided by 2. We're going to put this into bracket to show that we do the left and right first. So in this case, that will be 0 plus 4. 4 divided by 2 is 2. So 0, 1, 2. This will be our middle, right? Logical. And this is pretty simple until now. And it is pretty simple if you just see the whole algorithm. And now we check the element that this middle pointer is pointing at. So that's 5. And there are 3 possibilities. If this target, luckily, is the middle, then voila, the element has been found and we return the element. But there's always more chance that the element is not the target. But in that case, if this element is more than the target, so if this element middle, if this middle element is more than a target, then we have the search space by doing right equals mid minus 1. So what we essentially do is move this right pointer to the left side, the right left side. So minus 1, right? So 2 minus 1 is 1 here. So right next to the middle pointer. And if it's the opposite, so if this element middle is less than the target, then what we should do is we move the left pointer in this case to reduce the search space to the right side of the middle pointer. So that would be in this case 3, right? So if we get to this point without finding a target, then the search was unsuccessful. And we do this again and do this again and do this again. And at worst time complexity, it will still have log n. So it's really, really, really fast and efficient. And that was pretty simple, right? I'm first going to show you guys a template. So this is a template that I got from internet. Shout out to Liao Zhao Jun. He's a pretty famous figure, and he's written quite a lot of templates. So I'm pretty sure if you search this template online, you'll find him. But anyways, what he essentially does is, yes, you define the condition based on the problem. And just 1 second. And while left and right are initialized to the start and end indices, and while left is lesser than right, the mid pointer is left plus right minus left divided by 2. If the condition mid, so the element that the mid pointer is pointing at, if the mid is calculated as a mid element between left and right. And if it is true, it means that the target for target is at mid and you have found the target. But if not, then mid is false. So it means that target is to the right of the mid and left is updated to mid plus one. So yeah. So example uses, as you can see, array is 1, 2, 4, 4, 5, 6, 7, and the target is 4. Binary search will first find the first occurrence of 4, which is at index 2. And yeah, and this will use this kind of template. Now we're gonna do some questions, 2 easy questions. I feel like the best way to learn this is to tackle some questions. So thanks to the Leetcode, we have plenty of questions. This is the first question is binary search, the binary search itself. So we obviously know that we have to use binary search algorithm for this one. So let's go into it, shall we? Let's see. So to achieve O log n, we know that we would have to use binary search. What the question is asking is to find a target, right? If the target exists, then return its index. Otherwise, return -1. Here, the target is 9. If we use the binary search, we know that we go to the middle pointer and then see if the target is on the right side of the middle or the left side of the middle. And since it's on the right side, we move the left pointer to plus uh, to the +1 of it, and then so on and so forth. So 9 exists in nums and index is 4. If it doesn't exist, we return -1. So as we see from templates, let's just copy and paste the template. You know, sometimes it works, sometimes it doesn't. But usually on this kind of array question, it works more than it doesn't. So for a newbie like me, I feel like this is the best way. Just memorizing the template and then tweaking a bit. So we know that we're going to use this binary search. We initialize the left and right pointer like this. We initialize the binary search loop. So the loop runs at as long as left is less than to right. We check the mid value. If nums mid equals target, then we return mid. So I would say we change this because now we don't have conditions. Nums mid. Well, left is less or equal to right, right? And mid is equal to left plus right. Okay, let's just change this also. Right plus left. And this has to be the length of the nums, left and right. Nice. So now, if the element that the mid pointer is pointing at is equal to the target, so if nums mid is equal to the target, then we have already found the target, right? So we return this indices, so that will be mid. Okay, a leaf, if it's smaller than the target, smaller than target, if the mid pointer is smaller than the target, Then we changed this mid-pointer to the right side of the we change the search space. So we do that by moving the left pointer to the right side of the mid, right? So that would be left equals mid plus one. That's correct. And we have another condition. If Dumb's mid is more than target, then we would have to specify the right, which is mid minus one. So we move the right pointer to the left of the mid pointer so that we reduce the search space, and ultimately we keep on reducing this binary search space to find the indices of the target. And if the search finishes and we haven't found the indices, then we return minus one. And let's see if this works. Okay, return mid. Yes. Square brackets. Huh? Outside function. If num's mid equals target, we return. Okay, this should be while left mid equals. Let's see if this works. Yes, so we can see that it works. We just tweaked the template a little bit. Actually, that was quite a bit, but if you just follow the logic, it's not that hard. It's just specifying the if else condition for the mid pointer. We don't even have to do that much with left and right pointer like we did in two-sum or the sliding windows. So that was pretty easy, I would say. Now we're going to move on to the next question. So for disclaimer, binary search can only be used on as for now, can only be used on the sorted arrays. We're going to, of course, explore the other cases where binary search can be applied on different type of structure. But for now, for today, we're only going to explore it on array. And this is another question that we're going to go through. We can already see that we have to write an algorithm with O log n. So at worst, binary search is O log n. So we have to use O log n. So how are we going to use this? So we define the problem. It's basically asking us the same thing, right? So we just find the output, the indices of the target. So in this case, it's 2. If it doesn't exist in the nums array, then we return the output that this should have been in. So that is the one in between 1 and 3. So that's the indices of 1. And in test case 3, that is also the case. So we put it at the end of this nums array. So that is output of 4. So now let's put this template again. This is also the other template that I found from internet. Let's try with this one. Maybe this is better. So left is 0, right is length of array minus 1. In this case, it's nums minus 1. Now let's just put it like yeah, left 0. Okay, now while left is lesser than right, we also have to specify the midpoint, which is mid is equal to left plus right divided by 2. So we have this here. If the mid element is equal to target, then we have found the target. So we return its indices, which is return mid. Now, if the target is more than mid, it means that we have to put the right pointer to the one left side of the mid pointer. So in that case, that's right equals mid minus 1. So we have it here. And else, if it's lesser than the target, then left equals mid plus 1. And if it is not in the array, but left is at the insertion point, we return left, right? Because we just put it at the point that the target is supposed to be located at. We didn't even change anything. Let's see if this works. Okay. Expect an indented block. Let's see. Name array is not defined. Nums. Let's see. Hey, voila, it worked. So we just simply changed 3 or so, and then it still works. So I guess this template also does a nice job at that. So guys, if you guys need it, just comment down below and then I'll share it with you guys. Or you can just search it online. It's everywhere if you just binary search template. But anyways, guys, that was it. We looked at the simple use case of the binary search template, and at worst time complexity, it is at log n, and how it basically works. Tomorrow, we're going to look at a more complex use case of binary search and try to solve an example case. And yeah, thank you guys all for listening. And if you guys have any comments, like usual, comment down below. And yeah, see you guys tomorrow.